QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let us consider this given quadratic equation. Is this trinomial on the left-hand side factorable? Yes or no? The correct answer is yes. If this is factorable, what are the factors of the given trinomial? We have x plus 7 and x minus 2. With this, what are the roots of the given quadratic equation? And the roots are -7 and +2. Did you get 3 over 3? If not, please continue viewing this video. The task here is to come up with the roots of this given quadratic equation here. We have several methods for that. For the past few videos, we use extracting square roots because b coefficient is not around. We also use the common number factoring because c is not around. And we also have a quadratic formula that have yet to be presented. But we are going to use here specific methods as well. Now for a complete quadratic trinomial just like this is considered to be complete because A is 1, B is 5, and C is -14. This is an example of a complete quadratic trinomial. In short, this would be that we cannot use extracting square roots nor the common number factoring, but still there is a portion of factoring that we make use here. If we have a quadratic trinomial or complete quadratic trinomial, we have 2 separate methods. It's either by factoring or by completing the square. So we are going to differentiate the use of 2. Now we can say whether we use factoring if this is factorable, and if it's not factorable, we're going to use the completing the square method. We can solve that by considering AC. AC is the product of A, which is 1, and -14, which is our C. So the result here is -14. We are going to look for factors of this result for AC that when added will result to B. If there is, then this is factorable and we proceed with factoring. If it doesn't have any pair of factors that can result to 5 when added, then this is not factorable, hence we use completing the square method. The factors for this will have -1 and +14. We can also have -2 and +7. We could also use +1 and -14, as well as +2 and -7. Okay, so which of these 4 pairs of factors that of course they are called factors because when they are multiplied to one another they will result to -14. Which of this pair will result to 5 when they are added? In short, if we're going to add this one, add this pair as well, and add this pair, which of these will result to +5? We have actually this pair, the -2 and +7. -2 times 7 is -14, and then -2 plus 7, you will get +5. With this, we are sure now that the quadratic trinomial here is factorable. Again, if we cannot look for any of the pairs that will satisfy the condition, this means this is not factorable. And since this is factorable, let's proceed to factoring. Okay, factoring is one of the most efficient way of getting the roots, as it could be used for factorable trinomials like this. And in factoring here, we'll have x. We have two binomials with first term x, and we are going to pair it with the coefficients used as factors of AC and as addends to your b. So you'll have x minus 2 and x plus 7. Of course, you could also use x plus 7, x minus 2 for multiplications commutative, and they have the same result. These are the factors of the quadratic trinomial. And since we are looking for roots, let's not forget the use of equal to 0. Now that we are done with the factors, we are going to use here the zero factor or the zero product property. And that tells us that this is only true. These two factors or the product of these factors will only be equal to 0 if one or both of these factors are equal to 0. In short, this situation is only possible if x minus 2 equal to 0 and x plus 7 is equal to 0. And we'll solve them independently. The first root is x sub 2. And the second root, let's say x sub 2, is negative 7. They are called roots or solutions because they could make the entire original equation true. I'm gonna leave that checking to you. But these are the roots, and you can interchange them. You could use this as x sub 2, x sub 1. Nevertheless, we have the same roots for this given quadratic trinomial using factoring, because then again, this quadratic trinomial is factorable. So this is the discussion for this QuadQuiz. Subscribe now.